Good morning, students. This video is for grade 6th, subject science. Block 25, making magnets. LP2, how to make a magnet. Students, in the previous LP, we discussed about natural and artificial magnets. While in this LP, we will see how to make a magnet. The aim of this lesson is to explain the process of magnetization by stroking. The keyword is stroking. The resources required are iron bar, bar magnet, metallic paper pins or iron filings, S2 of volume book, science notebook and Exceed content book. Before starting the activity, I hope you will arrange all the materials available at your home. Now let's think and try to answer these questions. What are magnets made of? What are the different types of magnets you have seen? Is it possible to make a magnet? How? Magnets are made up of magnetic materials. Only lodestone or magnetite is found in nature. But most magnets are made artificially using magnetic materials. Bar, ring, cylindrical and horseshoe magnets are made from iron. Here are some types of magnets in the picture. These names are given on the basis of different shapes of the magnet. So today we will find out how to convert an iron nail or an iron bar into a magnet. Let's perform the activity by pausing your video and arranging the materials as a resource. Try to pick metallic paper pins with the iron bar and observe what happens. Then stroke the iron bar several times, around 20 to 30 times, with one pole of the bar magnet. Students, bar magnet consists two poles, south and north. So you can take any of the pole and you have to stroke it over the iron bar to which you want to make a magnet. And your stroking should be in the same direction. Now try to pick the paper pins again with the iron bar. Record your observations in your notebook. Now again resume the video and try to answer these questions. What did you observe when the iron bar was brought close to the iron filings? What did you observe when the iron bar was stroked with the bar magnet and brought close to the iron filings? Or you can take a paper pin. An iron bar is made of magnetic material but is not a magnet itself. Therefore, it is not able to attract the iron filings. The iron bar gets magnetized after stroking it repeatedly with a bar magnet in the same direction and with the same pole. This magnetized iron bar attracts iron filings. You can see how the stroking is done by taking a bar magnet over a piece of iron. You have to select only one pole and you have to stroke it again and again repeatedly over the iron bar. Why does an iron bar get magnetized when it is stroked repeatedly in one direction with a bar magnet? Does the bar retain its magnetic property even after we stop stroking? How do you know that? How can you magnetize an iron needle to use it in a magnetic compass? So let's find the answers. An iron bar is considered to be made up of several smaller particles. Each of these particles is like a small magnet. In an iron bar, these smaller magnets are placed in any of the direction. When an iron bar is repeatedly stroked in the same direction with a permanent magnet, it gets magnetized as the smaller magnets get aligned in the same direction. Thus, a permanent magnet aligns the particles or the smaller magnets and converts it to a magnet. Let's see, students. The first bar which is being magnetized is a simple iron bar in which the tiny magnets or the small magnets are not arranged in a order. But when it is stroked with the permanent bar magnet or permanent magnet with a similar pole repeatedly, then you can see that these tiny magnets getting arranged in a proper order, which is shown in the second picture. Once these tiny magnets get arranged or aligned in a proper manner or in a direction, this bar will get magnetized and it will behave like a magnet. So this is all about the stroking process. Now any object made of magnetic material can be magnetized by stroking. We can magnetize a steel needle and use it as a magnetic compass needle by stroking with a magnet. After magnetization, if it is suspended, it will come to the rest in the north-south direction like a typical magnet and magnetic compass. The magnetized iron nail or iron bar and needle retain their magnetic property even after stroking it is stopped. If you keep stroking the iron bar for a longer time, what will happen? How will you prove that? So students, if the longer it is stroked, the stronger is its magnetic properties or the strength. We can attract pins by stroking different number of times. The number of pins the bar attracts will tell us the strength. It means if you are stroking more number of times, the strength achieved by that iron bar will be more. So children, what we learned today? We learn that how to make a magnet by taking an iron bar with the stroking method. Now try to answer this question or try to write this question in your notebook. What did we do to magnetize the iron bar? Students, you have to write the correct procedure and the steps which we are following to magnetize the iron bar. Now this is the homework time, so you have to finish your S2 volume book based on today's learning. You have to complete practice questions 4, 5 and 6 in your science notebook. Thank you students. Have a great day.